All right, guys, this is Kinesiology 234, and this is a follow-up to the NSCA Chapter 22 quiz, and it's specific to spinal cord injuries, multiple sclerosis, epilepsy, or cerebral palsy. And I did find a couple questions I thought were a little bit mooky, and I wanted to go over. So a complete spinal cord injury occurring between which vertebrae can lead to paraplegia? Now, paraplegia is 2, para. Quadriplegia is 4, and that's also known as tetraplegia. Those are kind of synonymous terms. And when you look at this in the book on 594, 594 lists that injury to the thoracic segments of T2 to T12 cause impairment of trunk, legs, pelvis, blah, 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 for paraplegia, which is great. But if you actually look at this, and I jumped this out to the book here, and you look at this whole paragraph, this whole paragraph, you kind of have to read, oh boy, I'm moving all over the place. You have to kind of read through the whole thing in terms of paralysis. And when a person is paralyzed, you look at this and go, okay, wherever the break or the damage is in the spinal column, or it could be somewhere in the trunk, but usually when we're talking about spinal cord injury, it's going to affect everything else downstream. Like I mentioned, how you can have a nerve root issue and it affects everything downstream, but it doesn't affect everything in the trunk. So with quadriplegia and tetraplegia, one of the big considerations is where is the damage itself. And if we go ahead and take this a step further and we go back and revisit an old friend here, and we look at this, within this presentation we talked about the different levels of the vertebrae, and this provided a pretty good overview too of the different nerve roots. And the quirky thing about, by the way, when you have these nerve roots, you'll have a C8 nerve root, although you only have 7 cervical vertebrae. That C8 is in between C7 and T1, but that's a nerve root that comes down. So if a person has an injury to their right shoulder and it damages something in the plexus, it'll affect everything else downstream. If a person has an injury in the lumbar region, they would end up being a paraplegic, because it wouldn't affect anything else upstream. Because remember, the signal and the impulses come from the brainstem down through the spinal column, and it branches out into everything else. So where the damage is determines where it affects everything else downstream. So if there's a break further up, and you have a break or damage up in the cervical area, then you're going to have tetraplegia or quadriplegia, same thing, where the arms as well as the legs will be affected. And so when you start to work with people, you start to determine some of these neurological dysfunction patterns, and you're able to pick things out a little bit better. And we talked a little bit further in this other presentation about nerve roots and how it affects other things downstream. But you get the idea. If there's damage anywhere in this whole system, if you think of it like a tree with a tree trunk, and then you have the different branches that come off of it, if there's a damage anywhere in the trunk, it'll affect everything else downstream. So let's now get out of this and go back to our presentation. I'm going to minimize this. So your big thing you have is, in this question, what they're really asking is, a complete spinal cord injury occurring between which vertebrae can lead to paraplegia? And their answer on this is, it's on 594, and they end up throwing out on its answers 2, 3, and 4. So go back to our picture, T2 to T3, okay, so everything downstream, L4, L5, L1, L5. Okay, that makes sense because we did everything up in this, anything up in the cervical area, and there was damage up there, then the person would be experiencing tetraplegia. So that's how I wanted you to kind of reframe this question. Think of it in terms of that analog we had up, that picture regarding the human body with the different nerve roots coming out of the spinal cord. All right, so this one just is pretty much just read, return, no problem there. There's another one that I thought was a little bit mooky, and when you read this, which of the following is the primary reason persons with spinal cord injury have impaired venous return? Lack of sympathetic tone, lack of parasympathetic tone, lower limb venous pooling, and absence of venous muscle pump. So a spinal cord injury, as it shows in the book, the way it reads is, particularly in the seated or upright posture, due to lower limb venous pooling secondary to lack of sympathetic tone and absence of the venous pump. So to me, I'm reading that lower limb venous pooling is secondary to these other two symptoms, meaning sympathetic tone is primary and the absence of a venous muscle pump is also a primary. But they look at it, and the way they write this in the test question is lower limb venous pooling. And I have a little bit of an issue with that because I think it's a little bit mooky. And of course, this sent me down a rabbit hole where I did a cut and paste and said, what is the primary? Just took the quiz question. What is the primary reason persons with spinal cord injury have impaired venous return? And that takes you down a pretty solid rabbit hole of information. If you so choose, you can look at these. And they're pretty good. I mean, in terms of 2010, 2017, 2012, they're fairly recent. You might have some legacy articles in there, but you'll find some good information. And I thought these were all pretty good articles. But at the end of the day, I really thought this question itself could probably have been written a little bit better in a manner that was probably a little less confusing. But nonetheless, just realize when you do this question, what we're looking for here is lower limb venous pooling. And what to do is when you read those articles, you'll notice there is a write-up in particular where they talk about the difference between sympathetic and parasympathetic tone and how people who have spinal cord injuries, that balance that's thrown off between sympathetic SNS and parasympathetic is upregulated or downregulates how the body responds in terms of stress. And depending where the spinal cord injury is, you can have an upregulation response on the SNS side to different regions of the body. So you'll find some pretty good articles in there. I thought they were quite good. This is pretty straightforward. You'll find this answer in the book. This one I thought was pretty okay, but it was oddly out of sequence in the book. Normally they do a good job of kind of having a sequential order to their questions. You'll notice this is on 602, and we're talking about spinal cord injury, so it's pretty straightforward. But now you go back to 598 for this question. So again, I thought this was a little bit awkward in terms of how they normally do things, but this one was a little mooky as well. They got close, almost got it, but you'll notice your choices are 5 to 10, 50 to 70, so it's not even in the ballpark of the 14 to 27. So you have to look at it and go, this is darn close and close enough for our test question, 15 to 30 versus 14 to 27. Now, if you take this to 7, 50%, you have forced vital capacity, and you'll probably recall that terminology from another class. Contractures. This was pretty straightforward as well. Contractures, shortening of the muscle tendons, got it. 9. This was also pretty straightforward. Now you have 40. So this is another one I thought was a little bit mooky, right? So your client has epilepsy and they've lost 15 pounds over the course of 12 weeks. What would be a valid concern? And the way they write this in the book is they present it as with a weight loss of 10 pounds, or even a modest weight loss of 10 pounds, inferring that anything over 10 pounds, meaning 15 pounds in the question, might have a relationship to the medications. Again, not totally confusing, but I just thought it was a little bit mooky that they are presenting it one way and then asking it a different way. All right, guys, I hope that helps. Good luck with your quiz.